Hello everyone, welcome to Chemazon-Complete Chemistry. So in today's video, what we are going to discuss about a structure determination. Suppose I give you some unknown organic compound and if I tell you to find out the structure of that compound, then which are the techniques, practical experimental techniques that we can use. So spectroscopy is going to be one of the most important tool that we use nowadays. It is most widely used all across the world for determining structure of very simple basic molecules to complex drug molecules as well. And we are going to discuss in this video different aspects of spectroscopy, which are the different types of spectroscopy. So what I believe is the structure determination is like solving a puzzle. Okay, each spectroscopic technique that we know that can act as a single puzzle piece and it gives you bits and pieces of different information about a particular organic compound. Then we can club all of them just like we join all the puzzle pieces together, and that's how we get the final structure of the puzzle, or we can say here it is the structure determination of the unknown organic compound. So every spectroscopic technique we can understand or think of like one single puzzle piece, and every spectroscopic technique is going to give us some little bit information about the unknown compound. So one of the technique is UV visible spectroscopy, then there is infrared spectroscopy. Then there is NMR, that is nuclear magnetic resonance spectroscopy, mass spectrometry. These are some of these spectroscopic techniques. There are many other, but these four are the most widely used techniques. So let us first determine or understand what is the meaning of degree of unsaturation. If we find out the degree of unsaturation of any organic compound, what information do we get? Okay, first thing is we come to know if any unsaturation is present in the molecule or not. What is the meaning of unsaturation? Before that, let us understand what is the meaning of a saturated compound. Saturated compound means compounds containing carbon-carbon single bonds. So we are talking about the most simplest functional groups that are alkanes. These are saturated. Saturated in terms of hydrogens. Okay, we cannot add more hydrogens in alkanes. Whereas if we talk about alkenes or alkynes, we can add more hydrogens or we can do hydrogenation to form saturated compound. So unsaturation means there is deficiency of hydrogen. Deficiency of hydrogen. We can add more hydrogen. So we can come to know by finding out the degree of unsaturation, we can come to know whether a compound has any unsaturation, which means it has any double bond or triple bond or a carbonyl group, or if any ring is present, a six-membered ring, a five-membered ring, or a cyanide group is present, wherever there is pi bonds or there is a ring present in the molecule, that we can come to know with the help of degree of unsaturation. By finding out the degree of unsaturation, we can come to know that. Next is mass spectrometry. This is another very important technique that we study for determining what all things we can come to know by studying mass spectrometry. First is we can come to know the molecular weight of a particular compound. Okay, we can come to know the molecular weight by what? By analyzing the molecular ion peak. Okay, from the mass spectrum, the molecular ion peak give us the information about the molecular weight of that compound. Then what we can come to know whether if any isotopic peaks are present or not. For what? For carbon, that is carbon 13 is present or not. That similarly we can determine for bromine, for chlorine. Okay, we can also come to know if any heteroatom like sulfur is present or not. Then what else we can come to know? We can come to know the molecular formula. Okay, from the molecular weight that we have determined from the molecular ion peak, we can determine the molecular formula by using what? By using the rule of 13. Then what we can use determine, we can determine whether nitrogen is present in the molecule or not by using what? You can by using the nitrogen rule. Then we can also understand the stability of the molecule. Some fragments that are separated we can come to know by using different fragmentation techniques that occur in mass spectrometric technique. We can come to know what all different fragments of the molecule are present in the unknown organic compound. So these are some of the information that we can get from mass spectrometry or mass spectrum that we measure. Next is UV visible spectroscopy. This is another very important technique that we use. UV visible spectroscopy is used for what? For the most important part is for qualitative and quantitative analysis of a compound. Okay, if I give you an unknown colored solution, then we can come to know its concentration. That is what we call it as quantitative analysis, which means we come to know the concentration, or if I want to talk about that, how much amount is present in the sample and what is present. That is, we can also come to know the qualitative analysis. We can do the qualitative analysis of a sample using UV visible spectroscopy. That is, which instrument do we use? UV visible spectrophotometer. What other information can we get from UV visible spectroscopy? We can come to know if a compound has any conjugation or not. Okay, conjugation means alternate double and single bonds. Okay, if any conjugation is present or not in a molecule, that we can come to know. And because of this conjugation only, some naturally occurring compounds like carotenes are colored in nature. What is carotene? Carotene is a pigment present in carrots. So the major role of this is we can find out qualitative and quantitative analysis. We can do qualitative and quantitative analysis of a sample. We can also find out whether a compound has conjugation or not. So these are the two most important uses. And for this qualitative and quantitative analysis, which law is involved? We make use of Beer-Lambert's law. Okay, now let us talk about the next important spectroscopic technique is going to be infrared spectroscopy. So infrared spectroscopy gives us the very important point is it gives us information about the different functional groups that are present in a organic compound. Okay, it gives us information about the different functional groups by studying what? By studying the stretching frequency of the compound. We will study what is the meaning of stretching frequency in much detail. It gives us about information about the functional groups that are present in an organic compound. Then if we want to find out if a compound has intermolecular interaction like hydrogen bonding, that also we can come to know. Next, what we can come to know from the next spectroscopic technique, that is nuclear magnetic resonance spectroscopy, or it is also called as NMR in short. From NMR, what information do we get? There are different types of NMR that we can study. Okay, related to, we can study 1H NMR. We can also study fluorine 19F. Then we can also study 31P and so on. So from this, what information do we get? We get the information that we get is about the bond connectivity. Okay, we get the information about how certain groups are connected to each other, how they are bonded to each other, that we come to know. Let's say if I talk about 1H NMR, we come to know about the connectivity about the different proton groups that are attached. Different groups of proton. Okay, how they are exactly connected to each other by studying what? By studying the splitting pattern. By studying the splitting pattern and also determining and studying what? Studying the chemical shift that we obtain from the 1H NMR spectrum. Okay, what else we can come to know? We can also come to know, suppose there are two isomers. Okay, we can come to know about the geometrical isomerism. Okay, suppose this is trans 2-butene and there is cis 2-butene. That is, if I want to determine and find out that which isomer is present, that is whether cis is present or trans is present, which alkene is present, that is we can study geometrical isomerism by using 1H NMR. How we can do that? We can do that by studying the values of coupling constant. Coupling constant gives us information about the geometrical isomerism of a alkene, whether it is cis or trans. So here we come to the end of today's video. In the coming video, we are going to start with the degree of unsaturation, and then we will one by one try to study all other spectroscopic techniques. Thank you so much.